Hey everyone, welcome to EduKaji. If your first time here, allow me to introduce myself. My name is Walter. I'm a real-life scientist as well as a chemistry tutor for the past 8 years. So this is the past paper discussion for SPM Kedah paper 2. Okay, so this is the Kedah state trial paper for year 2021, which is technically 2 years ago. And the reason why this paper is good is because it covers up almost every single chapter in your syllabus. So be looking to that. So let's take a look at the section A first, right? So this is for section A. And we can see over here, let's take a look at the first question. So the first question here says, one shows the state of three metals A, B, C, D of the same substance. So we have ice, liquid water, and water vapor coming out from the kettle. So what type of particle is found in B? So B is technically a liquid. So liquid are normally what we call as molecules. So for this case right now, don't write liquid, instead write molecules. Okay, so that's just one tricky question that they might ask you in the exam. Because students will see this and say, okay, this is a liquid particle. Actually, it's not, all right? They are referring to what kind of particles there is inside the glass of water, so that'll be molecules. For B, name the process when physical state C changes to A. So asking you what happens if you were to change from C, which is water vapor, back to A directly, which is solid. Now, of course, it's not referring to just water. It can be any other things. Maybe it can be like iodine vapor, which turns back into solid iodine, isn't it? So therefore, this one is actually what we call as deposition, correct? Deposition. So the process of changing gas back to solid is actually called deposition. So if you write that down, you should be able to get 1 mark. And then state the physical state of C. So technically speaking, C is supposed to be a gas. Water vapor is indeed a gas. So your answer here is supposed to be just gas. So there are different styles of questions they can ask you in just one single question. So just be careful not to lose any kind of marks. Make sure you read the questions properly, especially for the first one, the A, just now you see here, right? Type of particle over here. So it's not liquid, but it's rather molecule. For D, when B changes to C, state of change of heat energy. Okay, so B to C means from liquid state to gaseous state. So what will be the changes in the state of heat energy? So we'll say that heat is absorbed. Okay, to separate them, you have to break the hydrogen bond. So therefore, you can say here heat is absorbed. Okay, and then what happens to the force of attraction between the particles? You can say it becomes weaker. Or you can also just use one word, says weaken also can. So becomes weaker or weakens. Can be a choice of answer. So if you answer both correctly, you should be able to get 2 marks. Okay, all right, let's go to number 2 then. This is about cosmetics. So diagram 2 shows a few samples of cosmetics. State the meaning of cosmetic. So cosmetic is, okay, generally, okay, I don't think there's any defined definition of what cosmetic actually is, but I'll say that cosmetic is something to make you feel, okay, generally it makes someone's appearance nicer. That's one of it. Or it is also used to cleanse your face. Like, say, for example, face cleanser, right? Everyone uses face cleanser. So face cleanser could actually be one type, all right? One type of, what's it called, cosmetic product. And sometimes we can also use cosmetics to protect our face. So any one of those definitions can be used to describe what cosmetic is. So I would say generally cosmetics or cosmetic, cosmetics are products. Okay, products used to clean, protect, to make a person's appearance more beautiful, I guess. I wanted to say nicer, but it doesn't sound right. So therefore, more beautiful. So of course, everyone is beautiful on their own lah. Okay, it's just figures of speech. Now let's state two basic ingredients of cosmetic product. So anything that is added into the cosmetic product can be used as an answer lah. So of course, the first and foremost, we'll say, of course, every single cosmetic product will have water, right, as a solvent. So you can put there water. Okay, other than water, there's many other things like stabilizers, preservative, okay, what else? Moisturizer, sorry, coloring, scan, dye, moisturizers, colorings or dyes. So any one of those should be correct. And then let's take a look at the next question. B. So you say plastic bottles and nylon are example of products made from polymer. State two types of polymer. Generally, there are only two types of polymers lah. So the two types over here will be natural polymer and synthetic polymer. Okay, natural polymers and synthetic polymers. So let's move on to the next one, number 3. Benzene is a hydrocarbon found in crude oil. It is used as raw materials to make plastic dyes and pesticides. Structural formula of benzene is shown. So state the meaning of empirical formula. So empirical formula, again, is a chemical formula that shows the simplest ratio of the number of atoms of each element in the compound. So you put here a formula that shows the simplest ratio of each atom of each element in a compound. So that should be your definition of the empirical formula. Right, and then they ask you to write the empirical formula of benzene. So what I need to do now is to actually write out the molecular formula first. And if you calculate the number of carbon atoms over here, it'd be 1, 2, 3, 4, 5, 6. And hydrogen also be 1, 2, 3, 4, 5, 6. So your formula for benzene over here, the molecular formula is C6H6, right? So to get it in the simplest ratio is actually 1 to 1. And therefore, the empirical formula of benzene should be CH. So this is your answer. Okay, all right, next. B1, benzene undergoes chlorination reaction, all right, to produce chlorobenzene, which is used in pesticide manufacturing. The chemical equation involved is as given. So you got C6H6 plus Cl2, you get C6H5Cl plus HCl. So it says here, if 1.5 mole of hydrochloric acid is produced in this reaction, calculate the volume of benzene needed at room conditions. Now in this case here, benzene is actually a gas, by the way. Yeah, it is not a liquid, it's a gas. So right now, same thing, the hydrochloric acid is produced. After that, they give you the number of mole already, so it's easier for you. Okay, it says here that 1.5 mole of HCl is used. Based on the equation, it is 1 mole to 1 mole ratio. So therefore, if you have 1.5 mole of hydrochloric acid, you should also have 1.5 mole of benzene. So what you can do here is to write number of mole of benzene is equivalent to number of mole of HCl. And therefore, it will be also 1.5 mole. So once you get that ready, you can just multiply it by molar volume. So volume of benzene required will be number of mole, which is 1.5, multiplied by molar volume, which is 24 dm cube per mole. And let's see how much that is. 36. So 36 dm cube of benzene. Okay, get it correctly, you should be able to get 2 marks. Right, calculation 1 mark, and your final answer 1 more mark. Okay, if chlorine is replaced with bromine, write the chemical equation for the reaction. So all you have to do is just to replace the chlorine bromine and you get back the same answer actually. So that will be C6H6 plus Br2. You'll get C6H5Br plus HBr. The correct formula for each substance will give you 1 mark, and balancing the equation will give you 1 mark. But since there's no need for balancing on the equation, then therefore you just get 1 free mark. Okay, all right, let's move on to the next question. So number 4 now. Diagram 4.1 shows the electron arrangement of a compound formed between elements X and Y. So it's very obviously, this is actually the formation of ions. So it is ionic bonding. How the chemical bond is formed. So very simple. You can just say that it is through electron transfer. Okay, electron transfer from X to Y. But it's okay. Just write it through electron transfer will do. They give 1 mark already. Okay, let's move on to the next one. Based on 4.1, state the type of compound. The answer will be ionic compound. And after that, write the formula of the compound. So we have 1x and 2 y's. So the formula will be XY2. So usually the metal ion will come first. I mean, in the formula, metal ion will come first, followed by the non-metal. That's the sequence. So some strategy asks if that can we actually write Y2X? No, because we see the positive ion is actually X. So it's actually X first, then Y. So it's XY2. Next, figure 4.2 shows the arrangement of water molecules in liquid water and ice. Okay, so ice has a very nice symmetrical structure in one surface area, and then there is also liquid water which looks very chaotic, or it is actually very messy. So state the type of bond that exists between the water molecules. Okay, bond that exists between water molecules, that will be technically hydrogen bonding. Now, it says water is added into a glass containing ice cube. What can be observed? Explain the observation in terms of bond formation. So here, what happens is that if you have a ice cube placed into a glass of water, of course, the ice will float to the top lah. Okay, so that's the first mark that you will get if you write that. So you say here, ice floats on the surface of water. Okay, now because it's a 3-mark question, you have to explain how this is, what's going on lah. How is this happening? So we can say that ice has a lower density compared to liquid water. Okay, ice has a lower density compared to liquid water. And you still have 1 more mark left to explain why is that so. So you can say that due to hydrogen bonding, okay, when water freezes, there are lesser number of molecules per unit area, per unit volume compared to liquid water. So they give you another mark. They say as liquid water freezes, there are lesser water molecules per unit volume compared to liquid water. Okay, now of course this is all due to hydrogen bonding lah. When hydrogen bonding happens, it will force the water molecules to sort of like expand slightly outward, just to form this very nice geometrical structure that you see. All right, and that's why we see in one circle area that you notice that there will be lesser amount of water molecules in that 1 unit area compared to the other one on the right side. So there are more water molecules can be seen in the right side where it's liquid water compared to the one in the ice. So that should give you an idea to how to compare based on density lah. Okay, if you get all 3 marks, or if you release down all 3 points, then you should get all 3 marks lah. Okay. Let's go number 5. Diagram 5 shows the part of the periodic table of elements. So we have different alphabets to represent different elements. So it says here the letters A, B, K, L, M, and N do not represent the actual symbols of the element, but it is your job to know that you have to use those alphabets, all right, as your main answer. State the position of element L in the periodic table of elements. When they say position, they expect you to write it in terms of group and period lah. So L will be in group 16 and in period 2. So you put here group 16, period 2. Then you'll be able to get 1 mark. All right, which element exists as diatomic molecule? So usually the non-metals like in group 17 will usually be diatomic. So I will say M is most likely the case. So you can just put here element M. Okay, all right. C, 9.4 grams of oxide of element K reacts with 250 cm³ of distilled water to produce an alkaline solution. Okay, that's the highlight over here, an alkaline solution. So K is located in group 1, right? So it's actually a group 1 element. So they want you to write a balanced chemical equation for the reaction. Okay, now it says here oxide of element K, right? Since you know that O is 2- and K belonging to group 1 is K+, so the formula of the oxide of K is supposed to be K2O. So you start with K2O plus H2O, then you'll be able to get 2KOH. All right, and balancing the equation, you 1 mark. and the correct formula, you 1 mark. The funny thing is K is actually K itself. If you notice it, K is actually potassium, so it's actually K itself. Calculate the molarity of the solution formed. Okay, now we have the mass of oxide K, and we have the amount of distilled water that's added into it. So the first step we need to do is to calculate the number of moles of this K2O. So K is 39, O is 16. Okay. So first we need to calculate number of mole of K2O. So number of mole of K2O will be the mass which is given, which is 9.4 grams. So 9.4 grams divided by its molar mass, which is supposed to be 39 times 2 plus 16. Okay, this will be gram per mole. So let's see how much that is. So 9.4 divided by 39 times 2 plus 16. The answer is 0.1 mole. Okay, so you get 0.1 mole already. And then now you have to find out your volume. So this volume is in 250 cm cube. We have to convert it to dm cube first. So 250 cm cube is equivalent to 0.25 decimeter cube. All right. So now to get the molarity is equivalent to 0.1 mole divided by 0.25 dm cube. You will get exactly 0.4 mole per decimeter cube. Do everything correctly, you should be able to get 2 marks. Okay, now we have D. Elements A and B are in the same group but have different reactivity when react with oxygen. Explain why there is a difference in reactivity between the two elements. So A and B apparently is in group 2, right? And they are both metals as well. So in terms of their reactivity towards anything at all, or in this case, oxygen, the one that is lower should have a higher reactivity because we know that group 1 and group 2 elements going down the group will have more, it'll be more reactive. Okay, so the reason why is very simple. The attractive forces between the nucleus and the electrons decreases because the size of the atom gradually increases. So therefore, very easy, you can say that element B is more reactive than A. Right, you can see that A is above and B is below. So B is more reactive than A. That should give you 1 mark because of a comparison. Then the second mark is to explain why. Why do you say the element B is more reactive than A? So you say here the attractive forces between the nucleus and the valence electron is weaker in atom B. Then you should be able to get 2 marks over there. All right, for number 6 here, number 6A, a student carried out an experiment to determine the value of the heat of displacement. Diagram 6 shows the setup for the apparatus used in the experiment itself. So you can see over here, magnesium powder is added into a plastic cup, and eventually it is reacted with 50 cm cube of 0.2 mole per dm cube of copper 2 sulfate solution. The following data was obtained. We have initial temperature of 28 degrees Celsius, and the highest temperature of the mixture is 48 degrees Celsius. Okay, so I'm not sure why is it theta 1 and 2 supposed to be not theta, but it's okay. So later on, you will notice that you have to deduct it to get your theta. So the difference should be 20 degrees Celsius. So then that'll be your theta for your calculations. Okay, so 20 degrees Celsius. Based on experiment, what is meant by the heat of displacement? Okay, now be very careful based on this question, right? This is not a general definition. This is what? This is a operational definition because they mentioned based on this experiment itself. So remember, whenever they say based on this experiment, you have to remember it is an operational definition. Sometimes it won't be so straightforward. They won't say things like, okay, define this word operationally, define this phrase operationally. No, they will just give you, based on this experiment, you should automatically know you have to define this heat of displacement based on this experiment itself. So heat of displacement is a heat release. Why is it heat release and not heat change? Because we already saw there's an increase in temperature, right? So it's definitely an exothermic reaction. So we can straight away write heat release. So it is the heat release when 1 mole of what? Of copper ions, or just copper if you want to, right? Copper is displaced from its own salt, all right, with its own salt by a more electropositive magnesium metal. Okay. So we are defining the term heat displacement using this very specific example. All right, why polystyrene cup is used in the experiment? Although you don't realize it's actually an error. They should mention plastic cup, plastic, right? So there's an error over here. Supposedly it's supposed to be polystyrene cup. So let's just assume that it is polystyrene cup. Just ignore the plastic cup over there. So why is polystyrene cup used in this experiment? So we will say that the polystyrene cup here used to minimize heat loss, okay? To minimize heat loss to the surrounding. Now, I actually mentioned this many times, but let me just annoying you one more time regarding this. Never use the term to prevent heat loss, okay? Because I still see some students actually write this answer down. They said to prevent heat loss. You can't prevent heat loss, all right? Every single material in this world, to a certain extent, have some sort of a heat conductivity. To say that it is to prevent heat loss means the heat will still be there forever. So which means 100 years later, if you leave the hot beverage inside there, it should be hot still. You know what I mean? So it's actually quite ridiculous to say that it prevents the heat loss. It doesn't, but it actually reduces or minimizes the heat loss to the surrounding. Right? Complete the ionic equation for the reaction that occurs. Now, for those of you who are professional in writing an ionic equation, you can straight write an answer inside, which is Mg2 plus Cu minus. Okay, now if you're not a professional in writing an ionic equation, then what should you do? You should write the half equation first. Okay, half equations for this, just want to extend this a bit, so just in case you don't know how to write half equations, I mean the overall ionic equation. So first and foremost, magnesium will turn into magnesium ion, right? Because it is displacement reaction. So this will be your first half ionic equation. And then the second half ionic equation will be when copper ions receive the electron or accepts the electron to form copper atoms. So this is the extended method to write an ionic equation in case you're not good at it yet lah. So what you can do is you can actually combine both together. So slash off the electrons as long as it is the same amount. Just cut off the electrons. If it's not, then you just balance it lah. Okay. Then after that, whatever is before the arrow you place together. So in this case, magnesium plus copper ion, you place them together, and whatever that's after the arrow, you also place them together. There you go. So you notice that this is actually the same as the top one, right? So it's up to you. If you're good at it, then you can write it down straight away. If you're not good at it, then you can do the long way. All right. Anyway, it's just like a few minutes extra lah, so you won't actually waste too much of your time also. It's better get it correct rather than to get it wrong. So if question comes up for operational definition, we can just put a substantive name in, but it's still the same writing in the form general definition. Correct. So which means you're using the same definition as the one that is general. It's just that right now we replace off certain words with a more specific term, like the metal name. It doesn't mean that you cannot use back the same definition. You can. It's just that, you know, in a general definition form, we always say heat release when 1 mole of metal is displaced by a more electropositive metal, for example, isn't it? But in this case, we don't want that because it's a very specific experiment with very specific example, right? So we're not going to use back the word metal. We're going to replace it with a specific metal. Then okay, really long, technically lah. Okay, number 4, calculate the heat of displacement in the experiment. So we have all the information that we need. We're using 2 different formula. The first one will be Q is equivalent to MC theta. And the second one will be delta H is equivalent to Q over N. Okay, so for the M, let's take a look at it. For the N, the M will be the mass. So we have a total of 50 cm cube of copper 2 sulfate solution. So assuming that density of the solution is 1 gram per cm cube, so 50 cm cube means 50 grams. So your M here is going to be technically 50 multiplied by the specific capacity of water, which is 4.2, multiplied by theta, which we saw the sum was 20, isn't it? 48 minus 28, which is given here. So that's 20. If you were to calculate that, let's see how much we get. So 50 times 4.2 times 20, you have 4,200 joules. So before that, before calculating delta H, we're going to make it into kilojoules. So we divide 1,000 and get 4.2 kilojoules. The next step is to now get N before we can calculate delta H. So N is equals to number of mole. So to get number of moles, very simple. You have the solution over here. 50 cm cube, 0.2 mole per decimeter cube. So you can use MV over 1,000. So you can use MV over 1,000 to get number of moles. So number of mole will be 0.2 multiplied by 50 divided by 1,000. So your answer will be 0.01 mole. Now that you get your N already and your Q is ready, you can then substitute the value into the delta H over here. So Q will be 4.2 kilojoules divided by 0.01 mole. So that will be, your answer will be 420 kilojoules per mole. Now, are we done? Not yet. Remember to put the negative sign here to show that it is an exothermic reaction. Regardless of whether it is exo or endo, you still have to put the plus or negative sign. Okay, even if it's endothermic, If it's positive, you must put a plus sign over there, or else it's not counted. So if you do everything correctly, you should be able to get 3 marks in total. Done. Okay, let's move on to the next one. B. Table 6 shows the heat of neutralization of 2 sets of experiment using different acids reacting with potassium hydroxide solution. All right, so the first one you see here, acid J plus potassium hydroxide. You get negative 55 kilojoules per mole. And we have set 2, which is acid K, reacting with potassium hydroxide, and you get minus 57 kilojoules per mole. So in terms of heat release, set 2 releases more heat compared to set 1. So in your mind, you should be able to tell why is acid J reacting with KOH is lower amount of heat release compared to acid K lah, because they have different strengths, right? Acid K is technically a strong acid, while acid J is a weak acid. So if we mention that, you're 1 mark already, because see, the next question here says, explain the difference in the values of heat neutralization between set 1 and set 2. So in this case here, very simple. The first mark you can get is when you say acid K is strong while acid J is weak. Okay, acid K is a strong acid, but acid J is a weak acid. So they give you 1 mark already. So second one, I have to explain why is it like, weak and why is it strong lah. So you can say that acid K ionizes in water completely. All right. But acid J only ionizes partially in water. So then, of course, you get 2 marks already. All right, the second mark is by the second explanation. And then the third one, which is sometimes students don't get it lah. So why does J, being a weaker acid, will not be able to have a same amount of heat release, isn't it? That is because some of the heat that is released in the reaction is used by the molecules to ionize, to produce even more H+. So to answer the question is very simple. You say here some of the heat release by reaction between acid J and KOH is used to completely ionize acid J molecules. So again, what does this mean is that, okay, so if you remember the definition of the heat of neutralization is when 1 mole of water is formed from H+ and OH-, right? So if you have a weak acid, you ask yourself, in the same concentration and volume with a strong acid, does it make sense to you that if 1 mole, both can produce 1 mole of water in the same time? Cannot. Because like I said just now, there'll be a partial dissociation of the weaker acid. So because of that partial ionization, there will never be a chance where acid J will be able to form 1 mole of water given the same volume and concentration lah. However, if let's just say some of the heat that is being produced when acid J releases the hydrogen already, the hydrogen go and neutralize the OH-, and some of the heat is used to break down more acid molecules until all of the acid J molecules have been ionized completely. So that's why some of the heat is lost in that way lah. Is absorbed by some of the molecules to ionize some more to release more H+ until it gets 1 mole of water technically. So That's the reason why. If you write that down, you should be able to get correct. So number 7. Diagram 7 shows a apparatus set up to determine the rate of reaction between hydrochloric acid and zinc metal, in which the hydrogen gas is now collected inside a gas syringe. So based on the diagram above, what is the meaning of rate of reaction? Again, this is an operational definition question. Based on the diagram above. All right, it's a bit tricky in the sense that it's separated out from the main question, but it's still based on the experiment, okay? So based on the diagram above, what is the meaning of the rate of reaction? So rate of reaction over here is the changes in the H2 produced over time, okay? Or the amount of H2 collected over time. That's the rate of reaction. So you put here, rate of reaction is the amount, or if you want to put volume also again, volume of H2 gas collected over time. Then you get 1 mark. Okay, then of course next will be state the observation in this experiment. It's a very easy one. When you add zinc chips in the hydrochloric acid, you should be able to see bubbles of colorless gas being produced. Okay, so very simple way to describe this will be colorless gas bubbles are released. Okay, if you don't like that, if you want to cut it shorter, you can also say effervescence. Effervescence occurs. So both also acceptable. I think occurred would be better choice of answer. It's past tense. Then they ask you to write a balanced chemical equation for this reaction. So when zinc reacts with hydrochloric acid, you'll be able to get zinc chloride and hydrogen gas. All right, for D, if the experiment is repeated by using sulfuric acid to replace hydrochloric acid, predict the rate of reaction that occurs. So when you have sulfuric acid, you have a diprotic acid, meaning to say there'll be twice more hydrogen ions being produced compared to a monoprotic acid, such as HCl or HNO3. So you can see over here, 1 mole of H2SO4 can dissociate to produce twice the amount of hydrogen ions compared to a monoprotic acid. So when you have more reactant particles to react with the other reactant, then of course the rate of reaction will increase. Okay, so in this case, the answer is very simple. You can just say here the rate of reaction will be higher. Okay, the following part is a result of the experiment. So we have 0, 60, 120, 180, 240, 300. And then hydrogen gas collected over that time will be 0, 70.2, 30.9, 40.1, 45.3, and then 45.3. So the reaction actually ends at 240 seconds in total. Based on the result on the table, calculate the overall average rate of reaction on the experiment. So overall average rate of reaction means total gas collected over total time taken. So here, rate of reaction is equivalent to 45.3 cm cubed is divided by 240 seconds. So your answer should be 0.189. 0.189 cm cube per second. If you want to run it off to the nearest 2 decimal point, also can. So it's 0.19 cm cube per second. Both also acceptable. All right, then next, calculate the average rate of reaction in the 3rd minute. It says here in the 3rd minute. So in the 3rd minute means you will have to deduct the 3rd minute, which is 180 seconds, and you have to deduct the one previously, the 2nd minute. So you'll be 40.1 deduct 30.9. So you put here rate of reaction is equivalent to 40.1, 30.9. Divided by 180 minus 120. So this will be your cm cube, and this will be your seconds. So your answer is supposed to be 0.153. All right, 0.153 cm cube per second. If you're running off the nearest 2 decimal point, you can do so. You'll be 0.15 cm cube per second. So that'll be your answer. All right, for the next question, F in a in a community, cooking event for a food carnival, Rizal has assigned to add potatoes as one of the main ingredients in the food. Explain how you can cook the potatoes quickly and state the factor involved. So this is also part of the rate of reaction lah. And of course, if you want to cook a potato, I would say cut it into small pieces, or you can increase the pressure up to you lah, whichever is possible. So I would say cut the potato better. So say here you can say Rizal you can either right there cut or slice the potatoes into thin layer. Either put thin layer or small pieces lah. As long as you indicate that the texture or the structure of the potato is smaller. Right, into thin layers or small pieces to increase the total surface area for the heat to cook the potatoes quickly. Then you'll be able to get 2 marks. Right, so the keywords such as the method itself, which is to cut potato slice into smaller pieces, and you have to explain why it works. You can say the total surface area will increase for the heat to react with the potatoes. You should be able to get 2 marks in total. Otherwise, an alternative method or alternative technique you can use is to increase the pressure by putting it inside a pressure cooker. That one also considered as an answer, where by increasing the pressure itself, the temperature inside will be much higher. Water technically will boil around 105 to 110 degrees Celsius. So that will be much higher compared to normal conventional boiling method. Okay, so that one can be also your answer lah. Depends on which one you're more comfortable with. Okay, moving forward to the next one, number 8. Diagram 8 shows 2 types of bicycle. One bicycle is made out of pure metal and the other one is made of alloy. Okay, so A, you can see over here, the guy is cycling a bicycle made of alloy, and B is the one that is a bit more rusty, although you can't really see it, but it's supposed to be a bit rusty. So state the meaning of alloy. All right, now this one you can use a general definition because they didn't say based on this experiment or based on diagram, right? So you can say here an alloy is a mixture of metals. Okay, it's a mixture of, okay, like two or more elements. I can't say metals actually because sometimes you got carbon inside to make steel, you know, carbon steel. So I say the better choice of word would be elements. Two or more elements in a certain composition. Okay, in which the major component is a metal. There you go, one mark. Right, based on diagram, choose which particle as a lighter frame. So right side, if you see, it's actually most likely iron, and the left side one is either aluminum or a mixture of aluminum and other elements, which is aluminum alloy. So based on diagram, which one is has a lighter frame, I'll say A is the answer. So A, you get one mark. Then I ask you to draw and label the arrangement of particles, okay, of the material used in A2. Now, you don't have to draw exactly for duralumin. You can just draw a typical, what's it called, a typical alloy structure, okay? But of course, if you know what are the elements that makes up the duralumin, then of course you can put it inside. You can either do duralumin or magnesium also can. So in this case here, you can just draw large particles, a few types, and then smaller particles around it. Okay, I will usually draw the smaller ones first, okay, to make sure that it is the major component. So we'll start by drawing clusters of grapes, and then you draw a bigger particle, and then start to use the smaller particles to surround that larger particle. And then try to also put, like, you know, maybe another one which is shaded, like this one over here. The shade a few will do because inside this particular alloy, supposedly there are 3 different elements. Okay, as long as you draw very obviously it can form this structure, then it should be okay already, I would say. Okay, so something like this. So then label it 3 different elements over here. So the first one will technically be the main element is the smaller ones. So the smaller ones will be your aluminum for sure. But bear in mind that this is not drawn according to scale. It is not according to the real scale. It's just a model. And then maybe you can put here as magnesium. And the last one will be copper. Okay, so this is how we draw the alloy of aluminum. So next, look into this. Uwais wanted to build a rack to keep dictionaries in the library in his school. Justify the usage of alloy to build the book's rack. Suggests an alloy that Uwais can use to build the book rack. So let's take a look at this. I would say here alloy is better. Okay, alloy is better to be used because it is more resistant towards corrosion, it is stronger, it is harder. Anything that you can mention about the properties of alloy, that should be good enough already. Okay, so we can say here steel will be my best because steel doesn't actually rust that easily. If you don't want, you can choose other types of alloy as well. Maybe duralumin, which is actually more expensive, so I'd rather use steel. Okay, so you say here Uwais can use steel alloy as a book rack. because it is harder, or you put that stronger if you want, and it does not rust easily. So give one example and explain the properties, two properties of that particular alloy. Then you should get 3 marks in total already. So no worries. Next, B, describe briefly how OYS tests the hardness of an alloy that he has chosen. Okay, this one is based on an experiment where you use a weight to drop it on the steel ball that it creates a dent, right? So you can just describe very briefly. This is not a designing experiment part because it's just 3 marks in total. So just describe very briefly how you can actually test the hardness of this particular alloy. So you see over here, you can say place a block of alloy on a table. Then place a steel ball above it or on top of it. Place a steel ball on top of the block of alloy. Okay, so once you have your block of alloy with the steel ball, then you say here, drop a piece of weight drop a piece of weight on the steel ball and measure the dent, the diameter of the dent. Okay, diameter of the dent produced. Repeat the test using a pure metal block. Okay, in this case, you can also use very specific examples. Like you want to say, place a block of steel, place a block of brass, place a block of bronze, okay? And then replace the pure metal. The pure metal can be replaced with copper, for example, a very specific example. So that there is no restriction in this case. Okay, as long as you write down at least 3 different points as the procedure very briefly, you should be able to get 3 marks from here. Okay, right? So that's a very simple example just to show you how it works. So as long as you get 3 points, then you should be able to get all 3 marks. Let's go to section D, question number 9A. Table 9 shows observations when a dry litmus paper is dipped into 2 beakers containing sodium hydroxide pellet in solvent P and solvent Q respectively to study the properties of alkali. So here solvent P together with the pellet of sodium hydroxide, color of the red litmus paper does not change. And then on the other hand, we have solvent Q in beaker B together with the sodium hydroxide pellets. You can see that red litmus paper eventually turns blue. So based on the table 9, state the chemical formula of sodium hydroxide, identify solvent P and solvent Q, explain why there are differences in the observations. Okay, so let's address the first question. Okay, what is the chemical formula of sodium hydroxide? So the first part here will be sodium hydroxide is NaOH. Right, it's NaOH. And then after that, the second question right now, done here, the first one, state the chemical formula of NaOH. And then I ask you to identify solvent P and solvent Q, explain the differences, very easy. So solvent P is most likely an organic solvent. So solvent P is most likely an organic solvent. So you can choose any type of organic solvent. So that would be either you can put benzene, all right, or you can just choose ethyl acetate, hexane, methyl benzene, and so on. Anything you can remember, any type will do, no worries. And solvent Q, which allows the sodium hydroxide to show its properties, will most likely be water. So by giving one example of an organic solvent as solvent P, and then water as solvent Q, you get 2 marks there already. So total you got 3 marks already based on explanation. Now I'll explain why when sodium hydroxide is added towards solvent P, there is no reaction. Okay, and then also explain why when in solvent Q, there will be a reaction. So you say over here, NaOH pellets cannot ionize in solvent P. No hydroxide ions are produced. Okay, no hydroxide ions are produced. So that should give you 1 additional mark for that. And then explain that NaOH in solvent Q can ionize, right? So ionized pellets, NaOH pellets can ionize in solvent Q to produce hydroxide ions. So based on this, you get 1 mark from here, you get 1 mark from here, you get 1 mark from here, 1 mark for explanation based on solvent P, and 1 mark based on solvent Q. Then once you get all this correct, you should be able to get 5 marks in total. Very simple explanation, okay, and also a very simple way to understand why we said that there is a reaction in solvent Q, but there is no reaction in solvent P. All right, don't worry about the answers, I'll give you later. All right, next, a student added 25 cm cube of 0.01 mole per decimeter cube of hydrochloric acid into 20 centimeter cube of sodium hydroxide solution. Calculate the concentration of sodium hydroxide solution. Determine the pH value of sodium hydroxide solution. 6 marks in total. Okay. So let's just write the chemical equation first. That's the easiest, huh? So we have HCl plus NaOH. We'll get NaCl plus H2O. So this is your equation. It is all 1-to-1 ratio, right? 1 mole to 1 mole. 1 mole, 1 mole, 1 mole, 1 mole. So it's all 1-to-1 ratio. It's very simple. Now we have the volume and concentration of HCl. So let's calculate the number of moles, and then after we'll compare it with NaOH. So number of mole of HCl, we can use the formula MV over 1000. So that technically be 0.01 multiplied by 25 divided by 1000. So let's see how much that is. So that will give you technically a very small 0.00025 mole. Okay. So now you will compare based on 1-to-1 ratio. You will also get 0.00025 mole of NaOH. Okay. So right now, to get the concentration of sodium hydroxide, given that you actually have 20 cm³ of it to neutralize HCl, so convert this to dm³ first. So 20 divided by 1000 will be 0.02 dm³. So concentration or the molarity of NaOH will be 0.00025 mole divided by 0.02 dm³. So your answer now will be 0.0125 mole per decimeter cube. Okay, so that will be the number of the concentration of sodium hydroxide. Now, we're not done yet because you can see here the question also want you to calculate something else. All right, calculate the concentration, done already. They also ask you to determine the pH value of sodium hydroxide solution. To get that, you need to calculate pOH and then only pH. Okay, so remember the key formula. pH is negative log concentration of hydrogen ions. pOH is negative log concentration of hydroxide ion. And then pH plus pOH is 14. So right now we can't use the first one, right? Because there's no hydrogen ions present. So we have to use the second one, which is pOH is negative log concentration of hydroxide ion. So sodium hydroxide dissociates in water to give you sodium ion and hydroxide ion, right? So it's a 1-to-1 ratio in terms of number of mole or concentration. So therefore, you see here, that's not calculated, right? The concentration of the sodium hydroxide is found to be 0.0125 mole per dm³. So it is also equivalent to the concentration of hydroxide ion. So therefore, concentration of hydroxide ion will be also 0.0125 mole per dm³ following NaOH concentration. So pOH is equivalent to negative log 0.0125. Let's see what you get. So you'll get 1.9. That's your pOH value. Do we stop here? No, we have to get the pH value. Now, using this formula, the second one, pH plus pOH is equal to 14. So what I can do right now is pH is equivalent to 14 minus your pOH that you calculated, which is equivalent to 14 minus 1.9. Your pH value of this particular solution is 12.1. So if we get that correct, with all the calculations, with all of the other steps that you did, right, quite a lot, you should be able to get 6 marks in total. So that's how you calculate pH value of a alkaline solution. If it's a pH value of a acidic solution, it'll be much more easier because all you need to have is the negative log concentration of hydrogen ions. But in this case, because we have hydroxide instead of hydrogen ions, we have to do the long way. We have to calculate the pOH first, followed by pH value, and then only deduct from there to get the actual pH value. Okay? Okay? All right, let's do one more. B, diagram 9.2 shows a flowchart of salt T. Okay, so salt T, when it's heated up, you get solid P plus brown gas plus colorless gas R. And then salt T plus Na2CO3, you get PbCO3. And then heated up, you get solid P and a colorless gas S. So if you want to solve the mystery of this, it's actually very simple. So salt T, when you react with sodium carbonate, you get PbCO3. So most likely this salt over here is a salt of lead, correct? So inside here, you got Pb2 plus already. The question now is, I don't know what's the anion, but when you heat up the salt T, you get a solid P and a brown gas, which indicates the presence of nitrogen dioxide. And if that's the case, then it is most likely that inside salt T, there is also a nitrate ion. So to solve that mystery, I would say that salt T is actually lead nitrate. And now that you know the identity of the salt T, you can then guess the rest quite easily, right? So solid P, after you heat up lead nitrate, you should be able to get lead oxide. So solid P is PbO. And if you heat up nitrate salt of a less reactive metal, you should be able to get oxygen gas as well. So colorless gas R is supposed to be O2. And then if you have PbCO3, if you were to heat up lead carbonate, you will also get the same thing, which is lead oxide, but at the same time can also release out carbon dioxide gas. So colorless gas S is actually carbon dioxide. So now that I've already solved the mystery of this mind map or a flow chart, then you can answer the questions rather easily. Okay, usually what I'll do is that I will solve the mystery first, because it's actually quite easy to solve if you know your chemical analysis very easily. Okay, if you're not good in your chemical analysis, then I think it's time for you to revisit the chemical analysis part. So see, the first question is always identify the substances P, Q, R, S, and T, so which we already did. So all you have to do is just to list it down all over again, which I'm not going to do that, but you can do it yourself. So salt T is this one, solid P is this one, Q is this one, R is this one, P is this one, and S is this one. Now bear in mind that you're supposed to name it, okay? You're supposed to name each and every substance, which means if it's lead nitrate, you must write lead nitrate. If it's lead oxide, you must write that lead oxide. You cannot write the chemical formula. In this case, that's for this case. Okay, so once you get all correctly, how many of those are? 1, 2, 3, 4, 5. 5 marks already. Okay, 5 marks in total. You get 5 marks over here. And then for number 2, salt T is a white solid. Describe a chemical test to verify the anion present in the salt, which is also very straightforward actually. What we're testing for right now is actually the nitrate. All right, so in order for you to test for nitrate, you have to add a few different types of solution. So we'll start with add a little bit of water and shake it until it dissolves. Okay, so the first step here is to add some water to salt T in a test tube. Okay, in a test tube. And after that, what we're going to do is that you're going to add a few drops of sulfuric acid. So maybe you can put a very specific amount, maybe add like 2 cm cube. Add 2 cm cube of sulfuric acid, dilute sulfuric acid, sorry. Okay, and then followed by two cm cube of iron 2 sulfate solution. Okay, then you say here, shake the mixture. And then after that, what happens is that you'll have to add a little bit more of another substance. So you say here, carefully add a few more drops of concentrated sulfuric acid. Okay. And then there will be a brown ring formation. So you put here, carefully add a few drops of concentrated sulfuric acid along the wall of the test tube. All right. And after that, you see here, a brown ring formation can be seen. All right, that's it. So this shows you the presence of nitrate ion. That's it. So for question number 10, the 10 shows the apparatus set up for the electrolysis of sodium chloride solution using carbon electrodes. And what you can see over here is that on the left-hand side, you will notice that there is a colorless gas being released. And on the right side, there's a greenish yellow gas release. So the first and foremost you have to do is actually to identify what is the anode and the cathode. So in this case, to determine which is the anode and cathode, we have to look into the battery orientation. So the longer rod will be positive, while the shorter rod will be negative. So this is the positive terminal of the battery, and this is the negative terminal of the battery. So in that case, what happens is that you should be able to tell that on the right side, the carbon electrode Y is actually the anode, and the carbon electrode X is supposed to be the cathode. So let's move on to the question. So based on diagram 10.1, state the factors that determine the products to be formed at the electrode X and also the electrode Y. So in this case, of course, if you notice, the solution that they use is actually 1 mole per decimeter cube of sodium chloride solution. Now, according to the chemistry syllabus, 1.0 mole per dm cube of solution is already considered as concentrated solution. Okay. 1 mole per dm cube and above is actually considered as concentrated solution. Okay, so in this case, what factors can determine the products to be formed at both of the electrodes? So it's very simple. It actually depends on your standard electrode potential value. Okay, so for electrode X, supposedly, your answer for electrode X is the standard electrode potential value. And for the electrode Y, it is actually the concentration of the solution. Okay, so this is the two answers for the number one here. That's more than number 2. Explain the reactions at the electrode X and Y. Name the ions that selectively discharge at each electrode. And then the reasons why the ions are selectively discharged, and also half equation for each of the reactions. So total got 8 marks over there. So for these 8 marks, right, you have to explain in terms of X 4 marks and Y 4 marks. That's how we can get the answers here. So I'm going to divide this into 2 different areas. One is for X and on the right side here is for Y. And we'll see how these marks are being distributed. So what they actually want from you is very simple. They actually want you to list down the list of ions on both sides. And then after that, name the ions as well that's selectively discharged. And then the reason why these ions are selectively discharged, and also the half equation for that particular discharge. So for X itself, since X is referring to the cathode, inside sodium chloride solution, there is actually 4 different ions lah. So NaClAq, you have H plus and OH minus from the water. And then you have from the salt itself, it will be sodium ion and also chloride ion. Okay, so the one that is going to be attracted towards the cathode, in this case, will definitely be hydrogen and sodium lah, because that is cathode, right? Cathode is negatively charged, so opposites attract. And then for the carbon electrode Y, which is the anode, which is technically positively charged, will definitely attract the hydroxide and also the chloride. So for the first point or the first mark that you get from X over here is, you can put here sodium and hydrogen ion are attracted to electrode X. Okay, and then for the Y side, you can put the chloride and the hydroxide are attracted to the electrode Y. Okay, so that's done. Give you 2 marks in total, 1 for X and 1 for Y. All right, and then after this is done already, and then the next one will be names of the ions selectively discharged at the electrode. So we will say that hydrogen is lower in the electrochemical series, so therefore hydrogen will be chosen for discharge. So you can put here H plus is discharge. Okay, and then on the right side, because it's more concentrated, right? So chloride will be chosen for discharge. Okay, then one is done already. You can move on to the next one. That will give you another 2 marks or so. And then total marks you can get now is 4. Then this is the reason why the ions are selectively discharged. Now, of course, because they want you to explain in terms of the standard electropotential value. So it's usually based on how negative or how positive it is lah. Okay, so in this case, then of course, the more positive it is, the easier to be discharged. So what you can say over here is very simple. You can just say that technically speaking, the standard electropotential value for H plus is more positive compared to the sodium. So you put here E naught value for H plus is more positive compared to Na plus. There you get 1 mark already. And then for the other side, okay, the other side, the explanation is a bit more different. For the other side, right, because it's based on concentration, so what you can say here is chloride is actually more concentrated than OH minus. So as long as you can put here, Cl minus is more concentrated compared to OH minus, then you'll be able to get another mark already. Okay, so total marks now is 6 marks now. And then for the half equation of the reaction is very simple. The one that is being discharged, you write the equation there. So for the X itself, right, the half equation will be, in this case, 2H plus 2 electrons, you get H2. All right, then they give you 1 mark. And then on the other side, for the chloride part, you can just put there 2Cl minus becoming Cl2 plus 2 electrons. So as long as you get all of this correct, you see here 4 points for X and 4 points for Y, you add up a total of 8 marks in total. So it's actually not difficult as long as you know how to write the half equations correctly. If you know how to explain the situation correctly, then you should be able to get these very easy 8 marks. All right, let's move on to the next question for B. Table 10.1 shows the standard electropotential values for the half cells for some metals. So we have P and Q, which is unknown. And then Mg and Zn will be magnesium and zinc, okay, in which they are not arranged in any particular order. It's just randomly placed to show you the standard electropotential values. So for number 1 over here, they ask you arrange the atoms and ions in table 10.1 in ascending order. Ascending order means from smallest to largest, or the lowest to the highest, of the strength of oxidizing agent and reducing agent. So you need to ask yourself first, how do we know which is which? Okay, now, the more, I would say, the more positive value it is, the more easily it is an oxidizing agent, okay? So oxidizing agent means the more positive, the better. For reducing agent, the more negative, the better. Okay, so in this case, we're going to arrange the first one, oxidizing agent first off. Okay, so for oxidizing agent, right, you see which one is the most negative first, because we say, right, for oxidizing agent, the more positive, the more likely you'll become an oxidizing agent, which means based on ascending order, we want to arrange them in terms of lowest to the highest, right? So lowest of oxidizing agent means the most negative value lah. Okay, so in this case, I would say magnesium will be the most negative. So in terms of that, we'll say that oxidizing agent, the lowest tendency will be Mg2+, followed by the second most negative one will be zinc. Okay, so zinc is the second one. And then we'll take the least positive one first, which is P. So P is only 0.34. So P 2+. And lastly, Q. So Q will be the most positive. So it's the highest chance of becoming a oxidizing agent. And then for the reducing agent, it's just the balik lah. Reducing agent means the lowest tendency will be the one that is the highest for oxidizing agent. And then you follow back the sequence, same thing. But in this case, it's not the ion, it's actually the atom. Because reducing agents, right, they tend to be oxidized. So therefore, they must be an atom first, then only can oxidize to become ions. So this one will start with Q, and then you put there P, and then followed by zinc, and then magnesium. Okay, again, you cannot put the ions inside because when they are reducing agent, they want to be oxidized. So in order for them to be oxidized, it is first an atom, followed by becoming an ion. So that's how we arrange the metals according to their tendency to become oxidizing agent and reducing agent in ascending order. Okay, so this is just a regular arrangement to show you lah. So if you get that correctly, you should be able to get 4 marks in total. And then they also ask you to suggest P and Q. Now, see, P and Q is a positive value. And if you were to recall back the standard electropotential values in your textbook, you'll be able to realize that this represents one of the lowest sequence, the lower part sequence of the ions. Okay, and if you notice here, Q is plus only, right? And P is 2+, and it's actually below magnesium and zinc. So the most likely, the one that is positive over here for P, it should be copper, right? P should be copper. And since Q, you see, right, it's only +1, right? 1+. The oxidation number is 1+, so it's most likely a single positive charge. So therefore, it should be silver, because most of the ions at the above it will be 2+, okay, except for silver and gold, which can form plus. So therefore, this is the answer lah. So you can get 4 marks in total if you answer all correctly. All right, and then for table 10.2 shows the reactants of 2 sets of displacement reaction of metal. So we have set 1, which is Mg plus Zn2 plus, and then number 2, P plus Zn2 plus. So based on your answer in 10B1, identify whether the reaction will occur or not for the set 1 and set 2. Explain your answer. Now I'll say that set 1, yes, there will be a reaction because magnesium is more reactive than zinc. Oh, but you cannot explain in terms of more reactive or less reactive. You have to explain in terms of the standard electropotential value. Why? Because you see, they already give you the values here. So they want you to use the values over here and make an explanation. So what we're going to say about Mg and Zn here will be, between these two pairs, we can say that the standard electropotential values of magnesium is more negative than zinc. So it is more likely that magnesium will displace zinc from its own salt because it has a higher standard electropotential value. More negative, sorry, that's what I'm trying to say. So here you can say that there's a reaction in set 1. Okay, very simple. In set 1, so I'm going to divide this to half, easier to write answers. So in set 1, reaction occurs. Okay, then to explain why, you can say that magnesium is a stronger reducing agent than zinc. Okay, then you say here is that Mg can be oxidized to Mg2 plus easily. They put there Mg displaces the N2 plus from its salt solution. Okay, so this is just an explanation to show how the reaction happens or what is going on actually. So we say that no, there is a reaction occurs, you get 1 mark. And then you say that magnesium is a stronger reducing agent than Zn, and it can be oxidized very easily. So magnesium can displace zinc from its salt solution. Now, how do we prove that it is a stronger reducing agent? Because it says here, based on your answer in B1, so we already mentioned in B1 over here that it is a stronger reducing agent, all right, for Mg compared to Zn. So what we can say here is that magnesium can actually displace zinc from its own salt. So that is based on B1 answer. Now for the second one, right, in set 2, no reaction occurs. That will be your answer. All right, no reaction occurs. And then of course you will explain why as well. So you can see here is that P is weaker reducing agent, right? Because zinc is higher, zinc is more negative. So P is weaker, is a weaker reducing agent compared to zinc. All right. So if you say if it's compared to zinc, then you say here it cannot displace zinc from its own salt solution. Okay. Then you say here P remains as is solid. And solution of Zn2 plus remains unchanged. Okay, so when I explain all these things here, you should be able to give you 6 marks in total. Okay, so therefore, it's just a very thorough explanation. Actually, you're supposed to just give 3 marks, 3 points for each side only, but I give you 4 points here just to explain to you in detail why it actually happens. Okay, but the maximum mark is allocated for each set will be only 3 marks. So even if you write extra points or whatsoever, you won't be able to get extra marks from that. It's just maximum 6 marks. So they'll pick the 3 best points and they'll give you marks based on that. That's it. Okay, but of course, the first one must be there. All right. Because they ask you whether there's a reaction or not, you must mention there is a reaction or there's no reaction. So that 1 mark from each side comes from there already. The explanation part is entirely up to you. As long as you can prove to them why one can displace the other while the other one cannot displace, then it should be able to justify it. Then you'll be able to get marks for it. Okay, all right, let's move on to section C. So in the section C, table 11 shows the information of 3 types of carbon compounds, PQR. For P, the characteristic of P is that it actually has less than 4 carbon atoms per molecule. Okay, so it says here less than 4 carbon atoms. Less than 4 carbon atoms. I'm just going to write it as this. And you can see here next, P can react with acidified potassium manganate 7 to produce a compound with sour smell. So is a sour smell is a characteristic for an acid. So most likely P is actually an alcohol. Okay, so pH of 7 is a neutral solution. Q has less than 3 carbon atoms per molecule, so it's less than C3. It is able to react with potassium carbonate solution to produce a colorless gas. So the distinct trait here is the carbonate, and the colorless gas is most likely carbon dioxide, and it can conduct electricity in a solution form. So I will say that if we can conduct electricity in a solution form, so among all the organic molecules, only one can conduct electricity in a solution form, and that is referring to a carboxylic acid. Why? Because in the carboxylic acid, they can actually dissociate in water to produce hydrogen ions, right? So like this is supposed to be either methanoic acid or ethanoic acid. And R, it has a fruity smell. Okay, when you say a fruity smell, it gives you an idea that it is actually an ester already, because ester is the one that smells the nicest compared to all of those organic substances. Okay, so it forms between reaction P and Q. So most likely this is referring to esterification between a carboxylic acid and an alcohol. So R here justifies further that, you know, the P and Q is actually an alcohol and also a carboxylic acid. Okay, let's move on to the question. Based on table 11, state the homologous series of compound R and general formula of compound P and Q. So the homologous series of R is actually an ester. Okay, so we put here an ester. R is an ester. And for P and Q, the general formula because you have to write general formula, so you must read the question properly. If not, if you don't read the question properly, then you won't be able to get the answer correctly, because you will think that, oh, I must state the group itself. So general formula over here is very simple. It will be Cn H2n plus 1 OH. And then for Q, the general formula of Q, if you were to write it correctly, it should be CnH2n plus 1 COH. All right, so that should give you 3 marks in total if you got it correctly, yeah? So that's the 3 marks you can get. Next, for number 2, by naming the compound, right? By naming the compound, PQR, describe briefly how can you prepare the compound R in school laboratory. In description, include chemical equation for the reaction. Okay, so right now, they ask you to name PQR. Probably ask you to suggest because they say some of them you can see, right? There is actually less than 4 carbon atoms and less than 3. So maybe for the alcohol, we can actually pick C2 and then carboxylic acid also C2 easier. So we can suggest P to be an ethanol and Q to be a ethanoic acid. That will make our life much easier because it's just 2 carbon atoms. So then R will be ethyl ethanoate. So if you can get all the names correctly, you should be able to get 3 marks already. So P will be C2, ethanoic acid, ethanol. Q will be ethanoic acid, and R will be ethyl ethanoate. Okay, so you got 3 marks here already in total. Now what is left is just 5 more marks to explain how you can produce this compound R, which is the ester itself, in the school. And also you must include a chemical equation. So chemical equation also will give you another 1 mark already, so it's easy for you. So let's describe it and see how we can actually write the procedure and then give the equation. I'm gonna write the equation first. Is simple. All right. So for the equation itself, it is supposed to be C3. CH2. Sorry, CH3COH. Yeah. Okay lah. CH3COOH plus C2H5. Sorry. C2H5OH. So when you combine it together, you get CH3CO C2H5. Not mistaken. Yep. Plus H2O. Right, but alternatively, let's just say you want to pick other types lah. Okay, if you want to pick other alcohol and carboxylic acid, right? Say for example, if you want to change it to methanol and methanoic acid, which is simpler, one carbon atom only, then your alternative chemical equation will then be like this also. Okay, so this is an alternative in case you choose methanoic acid and methanol. Okay, so you got two options lah. Okay, that's not giving another one, right? I gave you CH3 COH and C2H5OH. So the simplest idea is very simple. You have to remove the the OH from the carboxylic acid and the H from the alcohol. So if you were to combine them together, your product should be CH3CO, and then the O comes from the alcohol, and then just combine back last C2H5 and plus H2O. So you got two alternatives over here. All right. Now, as for the procedure, it is actually very simple. You just have to pour two different solutions together inside a test tube. And after that, you have to add a few drops of sulfuric acid, shake it strongly, and then after that, heat it up, and then you will have your ester already. Okay. So maybe I'll write it over here. The procedure is easier for you. So for the procedure to produce an ester, the first step is to pour 2 cm cube of ethanol into a test tube. Oh, sorry, into a boiling tube, because you need to boil it. Test tube cannot boil after you break. Okay, and after that, you can say here, pour also 2 cm cube of ethanoic acid into the same boiling tube. Okay, then after you say add a few drops of concentrated sulfuric acid. And then shake the mixture and heat the mixture. So that's the brief methodology or the very simple procedure you can do to get your the ester that you've been produced. Okay, so that's nothing much really to be honest. So if you write all that correctly, you should be able to get all 8 marks, which is rather simple. Okay, all right. So B, which is the thing, the final question. Diagram 11 shows the two types of fuel, A and B according to the composition commonly used in Malaysia. So we have methane and also butane. And then on the right side, B, you have a mixture of butane and also propane. So this one, right, this is actually butane. And this is methane. And then this one is propane. And this is butane. So it says here, both fuel are made up of mixture of hydrocarbons that burns completely in oxygen to produce carbon dioxide gas and water. Write a chemical equation when major component of fuel A and B burn completely in oxygen. So they ask you to write a chemical equation for the major component of both of the fuel when it burns completely in oxygen. So let's just write for A. I write A on top here. So for fuel A, and this is for fuel B. So the equation is very simple. You just write, I think the major component for fuel A would be methane. So when methane burns in excess oxygen, right, CH4 plus O2, you get CO2 plus H2O. But because you have to balance the chemical equation here, so you put a 2 here, you put a 2 here. Then it should be done already. So that's your balanced chemical equation. All right. And then after that, for the fuel B, the major component is butane. So when butane burns in excess oxygen, you got C4H10 again plus O2. You can get 4CO2 plus H2O. Then you try to balance it up to get the even number of oxygen. So here will be 5. But because it's an odd number, then what you can do is you can either put a fraction over here, okay? If not, you can actually multiply the whole equation by 2. So you can either write this, or alternatively, you can also write this if you don't want the fraction. So then you will get something similar to this. Okay, so one is with fraction and one's without fraction, but usually I will encourage my students not to write in fraction, okay, because it's easier for you to balance it if you were to get a very nice and even number. But you're not good. It won't be wrong, I'll say, if you want to write in fraction also, okay, since the marking scheme allows it, so you are allowed to write it up. So the last question, B2. Madam Marisa wants to buy cooking oil or cooking gas for the kitchen in the house between fuels A and B. Which one should she buy? Justify your answer from the aspect of energy release and also environmental issues. So this is more of like a keyword question also, because they want you to talk about the environmental issue and also the energy release. But I would say that it's very simple, just to explain, like when it comes to environmental issues, it's all about carbon footprint, all right? How much CO2 is being released into the environment and how does it affect climate change. So in this case here, you can actually write any choice of yours, all right? Recently, the trend is like they give you this option that you have to choose and you have to make your own decision. So there's no such thing as right or wrong when it comes to this question. It's more or less how you justify why you use A or why you use B, for example, okay? So in order for you to understand better, I'm just gonna, I don't have enough space over here, so I'm writing it over here. Okay, so what happens here is that you can just explain what is good in A and what is good in B. All right, so I'm gonna write A and B on both sides. Now again, I'm gonna repeat it one more time, just to remind you that if you choose A or B, it's up to you, and both also can be correct as long as you justify it correctly. So let's just say if your option were to be A, right? For example, if your option would be A, so why did we choose A? So of course you can say here A releases less heat compared to B. So this one will be release more heat. Okay, I'm just going to weigh out the pros and cons for both, because you see, right, when we talk about the major proportion of it, the major part of methane and the major part of the butane. So of course, if we compare between methane and butane, the more carbon atoms is the butane one, right? So butane, we're having more carbon atoms and a longer chain will produce more heat compared to A itself. This is according to the heat release stuff. All right, and then the second part you can write about this is also the number of carbon atoms per molecule, all right, and also the amount of carbon dioxide it can produce. So you can put here, you can say that this one releases less carbon dioxide. This one releases more CO2. Okay, and then you can say that lower percentage of carbon then to justify more, it will produce more soot. It will produce less soot, sorry. Then this one you can put here, higher percentage of carbon, it produces more soot. Okay, then of course you can also explain in terms of environmental impact. All right, so you can say that you can say that there's a higher chance that A will there's a higher chance of B having more environmental impact compared to A. So you say over here contributes less to greenhouse effect. And then you can see here contributes more to greenhouse effect. All right, so as long as you can justify and make comparison between A or B, then it should be good law. But even if you pick A or B, you get 1 mark already. So that's the good point about this question. Choose either A or B, get 1 mark. And then the rest of the marks, the 4 marks extra, will be all about justification, right? Which one is better, which one is bad. That's why I give you a comparison here for you to choose. If you choose A, you have to use the comparison and explain why. If you choose B, you have to use the experiment. You have to explain why in terms of the comparison also. So this will give you a good idea of how to answer the question itself, lah. Okay. So as long as you can answer 4 points in total, you should be able to get 4 of the justification point and also 1 for the option point. Then 5 marks in total. Okay. All right. So therefore, this is the only last question left. So I hope you guys have learned something from this, and you'll be able to continue to do your revision for your exams to come. So that's all for me today. I'll see you guys in the next video.